In this video, we're going to talk about boundaries. Boundaries are made of closed polygons. These can come from closed polylines, parcels, and surfaces. For simplicity, we'll be using polylines in our examples. There are 4 types of boundaries: outer, hide, show, and data clip. Each one is suited for different situations. The simplest type is the outer boundary. What the outer boundary does is exclude anything outside of your polyline. One example is when you have survey triangles and extra triangles that don't actually exist in the survey are added where the area scoops in. My example here has extra triangles, and I cleaned them up with the outer boundary. I've also set it to have destructive break lines. I chose destructive break lines here for 2 reasons. 1, I'm using the boundary to exclude extra triangles. And 2, my boundary isn't a hard edge that I need the survey data to conform to. An example of a hard edge would be something like a pond or a building pad. I'll now show you what a non-destructive boundary would look like using a hide boundary. The hide boundary hides anything inside the polyline. As mentioned before, this would be used for things like ponds, other water bodies, and building foundations. In these cases, that's when we would use a non-destructive boundary, since our boundary represents a hard edge. You'll see that with the hide boundary, the triangles go right up to the edge and maintain their original elevation where they intersect the boundary. If we look back at our outer boundary, you'll see that any triangles that touch the boundary are removed entirely. To make it clearer, I'll draw another hide boundary with destructive break lines instead. That's much clearer. Now that the triangles the boundary crosses over are completely excluded, and none of the triangles conform to the shape of the boundary, producing a jagged edge. If you need your surface to match up to the edge of your boundary, always pick non-destructive break lines. The show boundary is used in conjunction with the hide boundary. First, you have a hide boundary like we do here. Then you have to show your boundary inside it. We're going to use a non-destructive boundary since it's a hard edge. Anything enclosed in the show boundary is then revealed. An example of where you would use this is to show an island in the middle of a lake. The first 3 boundaries I showed you are easier to understand than the data clip boundary. To understand the data clip boundary better, I'll go into further detail on what boundaries do to data. What the outer, hide, and show boundaries do is chop out sections of data. It's easy to see because the chopped out sections are no longer visible and what's left behind can be used for calculations. Note that with these 3 boundary types, your original data is still retained, even if it's invisible. This is why we can adjust our polylines at any time to bring back data we previously cut out, and your surface can rebuild accordingly. The data clip boundary works in the reverse order, and once you cut out that data, it's no longer there, meaning you can't bring it back later. Let me show you what I mean when I say it works in the reverse order. I'll add in my data clip boundary, like I did with the others. Note that when the dialog box pops up, the option to choose whether it's a destructive boundary is grayed out. This is because the data clip boundary excludes data before the surface is created. Once the data clip boundary is applied, you'll see that nothing's happened visually. Like I said just now, the data clip boundary works by excluding data before the surface is created. So what we need to do is right-click the surface, go into Surface Properties, and click on our Definitions tab. In the bottom panel, we want to reorder our operations. For the data clip to work, it needs to be before surface creation. So now we select our data clip boundary operation and move it to the very top by clicking the first button on the very left. Once that's applied, you'll see that the triangulation of the surface has changed from before. What the data clip boundary has done is chop out data first, and then what's left over is used to build your surface. Now I'm going to edit my polyline for the data clip. As you can see, I can't bring anything back. The data clip removes that data entirely. Therefore, the data clip's main application is when you're given a massive data set and your project is only a small section within it. When you have a lot of data you don't need, it can slow down the performance of your file. Since the data clip removes unnecessary data, it's ideal for reducing your file size as well. And there you have it, all 4 different boundary types explained and demonstrated for different uses. Thank you for listening and have an excellent day.